Hey everyone, it's Justin again. In the last video, we looked at how inverses work on a graph. But in this video, we're going to learn how to find algebraic inverses even if there isn't a graph. With graphical inverses, the process is pretty easy. You find the points on the function and then swap the coordinates. Algebraic inverses are based on the same concept, swapping the variables. The difference is, first we have to rewrite the function so we don't confuse ourselves. Then after we swap the variables, we have to manipulate the function so that it's in the typical y equals form. But if we're talking about an inverse function, there actually shouldn't be a y, so we're going to have to change it back to function notation by rewriting the y as inverse of f of x. So there are technically more steps to it, but it's all things we've done before. Let's try an easy example. F of x equals 2x plus 4. First, we need to rewrite the function using y, not f of x. There, now it looks more like what we're used to manipulating. Next, we need to swap the variables. But now it's in a weird form. We don't want x equals, we want y equals. So we need to isolate y. Move the 4 to the other side by subtracting, then divide both sides by 2. Since we're used to seeing y on the left side, we can even flip the entire equation around. Finally, remember that this is the inverse of a function. Instead of y, write the inverse of f of x. The inverse of 2x plus 4 is 1/2 x minus 2. So now we know that these are inverse functions. But what does that mean? We've already answered that before. Inverse functions have swapped inputs and outputs. For instance, if we input 1 into the original function, 2 times 1 is 2 plus 4 gives an output of 6. If we turned that output into an input for the inverse function, half of 6 is 3 minus 2 gives an output of 1. And we're back to where we started. So, an input of 1 and an output of 6 from the original function becomes an input of 6 and an output of 1 on the inverse, just like when we were graphing. Next example coming up, f of x equals 1/3 x minus 1. First, that f of x will be hard to manipulate, so we need to replace it with y, and since we're looking for the inverse, we swap the variables. Now we need to isolate y. Add 1, multiply both sides by 3, then flip the equation so it reads y equals. Finally, we need to return it to function notation by marking it as the inverse of f of x. We can also see that these are inverse functions by graphing them. Here's the original function, here's the inverse function, and here's the line of reflection, y equals x. It looks like a proper inverse, but just to be on the safe side, we could even check some points. The point -3, -2 is on the original function, and its swapped form, -2, -3, is on the inverse. 0, -1 is paired with -1, 0, and 3, 0 with 0, 3. One more example. Pause the video and try to find the inverse yourself, then continue watching to see if you got it right. All right, let's find this inverse. Change the f of x to y, swap the variables, and isolate the y by subtracting 1/2 and multiplying by -6. Flip the y to the left side, and finally, rewrite it using inverse function notation. The inverse of -1/6 x plus 1/2 is -6x plus 3. You can check it using inputs and outputs or by graphing if you want. In future classes, you're going to learn how to find inverses of other types of functions as well. This completes our unit on functions. So look back over your notes and review past lessons if you need to. In the next unit, we're going to begin learning about a completely new topic, sequences, a way of creating mathematical patterns. See you then.